We want to take a look at solving equations and inequalities graphically. Here we have an absolute value function. F of x is the absolute value of negative 0.5x plus 5. And first, we want to take a look at when is that function, absolute value of negative 0.5x plus 5, equal to 4. With the absolute value function, keep in mind we do have that bounce. We look at where our value, function value, is 4. Now the function value is 4 at two places on this function. Our first point of intersection on the left corresponds to a specific x value. For us, we see this happens where x is equal to 2. The second function value where x is equal, where the function value is 4, corresponds to where our x value is 18. So for solving our equation, absolute value of x is equal to 4, we actually have two solutions. X is equal to 2, or x is equal to 18. One of these values would give us a positive number inside our absolute value. The other one would give us a negative number inside the absolute value. But both of them indeed do solve that absolute value problem. Taking a look at our first inequality, I'd like to know when is the absolute value of negative 0.5x plus 5 less than or equal to 2. So of course the first thing we need to check is where exactly is the function value equal to 2. And that will be all the way across this constant line. Again, we have 2 points of intersections. The first point of intersection looks like it lines up with where x value is 6. The second one will line up with where the x value is 14. We're interested in not where it's equal, but where it is less than or equal to. That makes a big difference. Well, the function value for our graph, less than, meaning below that value of 2, at all values of x. Starting at our first one, 6, going all the way to the right to 14. Using our set builder notation, we can say x is a value such that x is between 6 and 14. Notice we did have equality. It was less than or equal to. So each of these signs are going to carry the same less than or equal to symbol. Our lowermost value was 6, the uppermost value 14. Rewriting in our interval notation, again, the function value is below 2, less than 2. Starting from where x is 6 all the way until x is 14. Because we do have less than or equal to, we will have our bracket on the 6 denoting that 6 is included in the function values, and the same bracket on the 14 denoting that it is also equal to at 14. Lastly, we want to take a look at a different inequality. Here, absolute value of negative 0.5x plus 5 is greater than 4. Luckily, from the first example, we know that it equaled 4 at 2 and at 18. We want to know when is it greater than, meaning we want to know when is the function above. Well, the function f of x is above that value 4, all values to the left of 2. It happens again at 18. It would include all values to the right of 18. So for our solution set, we know that there exists x such that x is a value less than 2. Not an accident that the symbol points to the left, because it's all the values to the left of 2. Or it could be all the values to the right of 18. So x would be a value greater than 18. And because we did not have equal, we had strictly greater than, we have strict inequalities. X is less than 2 or x is greater than 18. We can rewrite these using our interval notation. When x is less than 2, we have all the function values. How far to the left of 2? As far as we can go. We start from negative infinity, and we never equal infinity, so it will carry a parenthesis. All the way to the number 2, we did not have equality at 2. So we will also have a parenthesis at 2, denoting that it is not equal. So from negative infinity to 2, that's all the values to the left of 2. Or, we denote that with our union symbol, it could be all values to the right of 18, meaning we start at 18, head on to the right forever, all the way to infinity. We never reach infinity, it carries a parenthesis, and because it was not equal at 18, we will also have a parenthesis at the value 18. So we have our graphical solution of an absolute value problem. And we're done.